Welcome guys, I'm Dr. Avitech, and in this video we're going to be describing functions analytically, and these functions are periodic, just that I did not want to write periodic so that the space would be enough, though I would have been able to do it, but so that's just what this video is going to be about. Remember to hit the subscribe button, like this video, and share it across to your classmates. Now always make the screen to be full screen, or should I say always make the video to be full screen, and at least watch the video at 720p. So let's get started. In the earlier video, we discussed how to find the period of non-sinusoidal waveforms or non-sinusoidal periodic functions. So currently, these are non-sinusoidal periodic functions. It's not looking like the sine wave. It's not looking like that. So the first thing I love to do before I describe a function is to first know the period of that function. So let's start with the first one. That's the easiest one. Let's start with the first one. Our solution. Okay, yep. Let me read a line here. Yep. So I'm just going to answer 5 questions. I'm going to be solving them in those part of the board. So the first one, before I say the answer, what do you think will be the period of this function? Before I say the answer, what do you think will be the period? The period is 6, because this is my start point 3. So I could just say this is 3, and then this is same thing here as 6. So I notice that when it gets to 6, it starts again. If you notice, when you add another 6 to this 6, you get 12. And again, it's starting again. So it is all beginning from this point, from the 3. Now, sometimes you can actually know your period if you describe a function analytically, because you might notice that when describing it, you get to a point and you keep getting the same values again. So when that happens, you know that, oh, I've hit the period, or I know what the period is. So the period of that function is 6. So let us describe from 0 to 6. That's the meaning. To describe a function analytically means you're going to be describing every single fragment that makes it up from start to finish. We know that the period is 6, and we know that the starting point is 0. So we're going to be describing this function. Every little thing that is in between 0 and 6 will be described. So now let us look at this. From 0 to 6. What is the first fragment? We have 0 to 4. From 0 to 4, this value remained the same. It was 3. From 0 all the way down to 4, it was 3. Please take note, when I say value, I mean f of x, or y value. So when x was from 0 to 4, when s was from 0 to 4, the value remained the same. The value was at 3. Then what is the next fragment? The next tiny part is 4 to 6. So from 4 to 6, what was the value of f of x, or value of y? Value of y was what? 0. Because it's laid directly on the x-axis. The value of y on the x-axis is 0. So right now, let us describe that function. It's actually very, very easy. So we know that f of x is equal to 3 from 0 less than x less than 4. Yeah, we are aware of this. So the value of y was 3, all the way from 0 down to 4. Now basically, I feel like since it's inclusive, since it was 0 at 3, I can put equal to here and equal to here. So this is what I kind of have. Now the next one is f of x is equal to 0. So the value of y was 0 from 4 less than or equal to x less than or equal to 6. Yeah, that was what it was. Though I think I should remove this less than or less than, but let's not discuss about the inequality. I don't want to do that. So after doing this, if you notice, if you wish to continue again describing it like this, you then go to 6 to 10, right? When you go to 6 to 10, you notice that, oh, I'm getting the 3 again. When you go to 6 to 10, when you say f of x is equal to 3, and this time around it was 6 to 10. You then be like, I've had this value before. And also, the distance between 6 and 4 is, 6 and 10 is 4. The distance between 0 and 4 is also 4. So it means, oh, I'm kind of having a repetition. So you could use this as an insight to know that, oh, I am actually going beyond the the single part that I'm looking at, because we're looking at just one period. So analytically describe every single fragment in that period. That's what we're trying to do. Okay. So currently, the beautiful way to write this is to say that f of x is equal, then you put curly brackets. So this will be 3 at 0 less than x less than 4. And then it was 4. Sorry. F of s was 0 at 4 less than x less than 6. So this will become the answer to the equation. And that's just it. If you wish, you can put equal to, please. I don't really want to start talking about the inclusiveness of this. If it was 3, if 3 was included when it was 4 or it was 0, I don't want to discuss that here. So this is what it's going to be. Now the next one, number 2. Okay, number 2. Now please take note, when you see horizontal lines, I think I'm going to discuss this in the next video, because the next video is going to be how to sketch graph. I'm going to discuss this in the next video. When you see horizontal graphs have no x contained in them. For example, if you notice, the first question here, our values were just numbers. They had no x contained in them because we're mostly dealing with horizontal lines. So this line was horizontal, this line was horizontal. So you can see that they had no x component in them. Now, but this very one would have an x component. So you have to be very, very careful. It has an x component. Now, when you go to question number 2, the line is not horizontal, the line is not vertical. It is slant. What does this tell you? From coordinate geometry, for the few persons who have done coordinate geometry, you would remember that whenever anything like this happens, it means we're talking about equation of a line. Yeah, y equal mx plus b, or y equal mx plus c. So that's what we're going to use to solve this very problem. When we're dealing with the first equation, you notice that the value of 3 remained the same all the way from 0 to 4. But if we come to question number 2, this value was not constant. When s was 0, it started increasing, started going up, and then down to this very point. You can see that, right? So it means that's not actually the same with the first one. So we need to know how to find the equation of a line. Yeah, we need to know. But let's start looking for the period first. What do you think will be the period of this function? I kind of know that the period will be 6. Now, why is the period 6? Because, I started from 0 and I increased upwards down to 2. If you look here again at this point, I started from 0 again and I'm increasing upwards again. And when you look at 12, it's also increasing even though it was not completed. So at every 6 seconds, at every multiple of 6, the graph is always repeating itself. And that's what period is. It's always repeating itself. So this is what we have. So let us get started. Since the period is 6, let us now describe every tiny part from 0 to 6, making up the graph. From 0 to 6, making up the graph or making up the period. So from 0 to 6. Now what do you notice? What's the first thing you notice? From 0 to 6, we had 2 parts. This is a line. So let me say this is OA. And this is another line, AB. So there are 2 lines making it up. So we need to find out what OA is going to be and what AB is going to be. That's what we're going to find out. So let us get started with 0 to 2 first. Now if you look at this, from this very point, this is always the origin, right? So this will be 0, 0. So when x for the first part, so at, or should I, any of them. When x is equal to 0, when s is equal to 0, y is equal to 0 also. Yeah, you notice that, right? When s is 0, y is equal to 0. Next, if s is equal to 0 and y is equal to 0, let's go to the next one. When x became 2, this is the x-axis, when x became 2, what was the value of y when s became 2? Value of y was also 2. So at s equal to 2, y was also equal to 2. What does this tell us? Now look at this. Before I say what it's going to be, what does this tell us? This tells us that basically any value that x take is the same value that y will take. Any value that x take is the same value that y will take. Because at 2 points, because to find the equation of a line, we need just 2 points. Or you need the gradient and 1 point. But in this case, we have no gradient, we have no slope. So you need 2 points. But looking at these 2 points, the value of x and y was the same. So this tells me that, y is going to equal to x. So that means f of x is equal to x. That's the meaning. Because for every single value I have for y, it's the same with the value of x. So now, at what point did this occur? This occurred from 0 to 2. So this occurred 0 less than x less than 2. That was where this occurred. Now the next one is to describe from 2 to 6. So describe from 2 to 6. So let's get started first. When x, I think I should put when here. So when x was equal to 2, we know that y was equal to 2 also, because right now we're discussing from 2 to 6. We're done with 0 to 2. We've been able to find the equation of the line as y equal x, or f of s equal to x. So right now we're dealing with this point. So at this point, this is 2 and 2. Now, when x was 6, we notice that y will be, or y be? Y will be 0, because it was at this very point. Take note, we're looking for a point here. This point here is 2, 2. This point here is 6, 0. Because since you are directly on the x-axis, the value of y is 0. The value of y is 0. When you are directly on the x-axis, the value of y is 0. So using this, let us find the equation of a line. The formula I love using is x minus x1 divided by y minus y1 equal x2 minus x1 divided by y2 minus y1. That's the one I prefer using, since I don't know the slope. So this will be x1, y1, s2, y2. So this will be x minus x1 is 2 divided by y minus y1 is also 2 equal x2, that's 6, minus 2, and then this will be 0 minus 2. Yeah, just to be a little bit fast so the video is not too long. So this is x minus 2, y minus 2, 6 minus 2 will give me 4, and then 0 minus 2 will give me minus 2. That's what it's going to give me. So this is x minus 2. I just recalled, I kind of flipped this formula. I think I would have put the y at the top. Still the same, sorry. But the next problem, so I'm going to put y at the top. I kind of like putting y at the top. Silly mistake. Or not really a mistake, but silly replacement. So this will equal to minus 2. Yeah, that's what it's going to equal to. So let's kind of expand here. So this will be x minus 2 equal minus 2 into y minus 2. Yeah, when you cross multiply, when you put over 1 here, 1 will times this. 1 times anything is that same thing. Then this will times this. Now see, please listen up. We are trying to make y the subject. There are different ways to manipulate this. We're trying to make y the subject. So instead of opening the brackets here, let me just divide by minus 2. Instead of doing it, let me just divide by minus 2. Divide by minus 2. So this is x over minus 2 over minus 2 equal minus 2 brackets y minus 2 divided by minus 2. So this will cancel this out. Now this will give me minus x over 2 plus 1, because minus minus will give me plus, and then 2 over 2 is 1, equal to y minus 2. Remember, I'm trying to make y the subject. So it means I'm going to bring the minus 2 to this other side. So this will be minus x over 2 plus 1 plus 2 equal to y. Now this is minus x over 2 plus 3 equal to y. So let me kind of rewrite or rearrange this. Let me put the y first. So y is equal minus x over 2 plus 3. Another beautiful way of writing this is to say that f of x is equal 3 minus x over 2. That's just the best. So let the 3 come first, then the minus x over 2 come later. Now, at what point did this happen? This happened at 2, because the value of s was 2, less than x, less than 6. So from 2 all the way to 6. Now, how do we then describe this? So we're going to say, I can roll that line. So we can say that f of x is equal, open curly brackets. Then we're going to say the first value we had was x, and this occurred at 0 less than x less than 2. Then the next one we had was this, 3, take away x over 2, and this was 2 less than x less than 6. And that will become your answer. That's just basically your answer. Now, another way to write that something is having a period of 6 is to say that f of x is equal f of x plus 6. What it means is, whenever you add 6, you're always going to get f of x back. So 6 is the period. So that's just another way to write it. Okay, number 3. As this space not too small. Okay, let's see if we can manage that. So question number 3. Remember to hit the subscribe button, like this video, and share it across to your classmates. So right now, we're going to be doing this. So let's see how best we can. If you notice here, what do you think is the period? I think that's like the easiest question. I don't even think question 1 is even easy. Question 3 is kind of looking like the easiest. So if you look at question 3, you can tell that the period is 8 actually. The period is 8. Yeah, because at every single point of 8, the function looks like it's starting again. It's beginning again. So if you notice also that in the multiples of 8, we have 8. When you add 8 again, you have 16. When you add it 8 to 16, you have 24. Just like that. So you can tell that, oh, the period is 8. And it's just a single guy, because from 0 to 8 was a straight line. So it's just having a single, should I say a single fragment? A single fragment from 0 to what? 8. That's what it's having, a single fragment. So that's what we have. So right now, we're going to try to describe this function from 0 to 8. That's just what we're going to do, because that's the period. So question number 3, let's get started. When x was 0, when s was 0, y was also 0. Because this is the origin, so it's always 0, 0. Then, when x was 8, y was 5. When x was 8, y was... Please take note, we don't really make use of vertical lines. Please, I think some people might be asking. We don't really make use of vertical lines. Either the lines are straight, either the lines are slant or horizontal, not vertical. Not vertical, please. Because vertical lines have no y component. Vertical lines have no y component. We're going to learn about this very soon. Vertical lines have no y component. And whenever we're describing functions, we're always doing so in terms of y. So vertical lines have no y component. This line you see here, this line here, let me say line CD. This line CD is just the line s equal to 8. It's just the line s equal to 8. So it's not described. You don't include that in your description. So you are either looking at slanted lines or horizontal line. That is what you're concerned with. Horizontal or slant lines. You're not looking at vertical lines. Leave them alone. They have no y components. They have no f of x components. So you don't include that. Okay, so let's find our equation of the line. Now, since everything is occurring at the origin, there's an easier way to reduce this formula. There is, but let me still write it so you understand. Y minus y1 over x minus x1 equal y2 minus y1 over x2 minus x1. There's actually a way I can explain how to get equation of a line very fast by understanding the concept of, what's it called? Concept of slope. The rise and the run of this function, by understanding it. But let's leave that. Okay, so this is y minus, I might upload a clip on coordinate geometry explaining what slope actually is. So this is y minus y1 was 0, right? So this is x1, y1, s2, y2. So this will be 0 over x minus 0 equal y2 was 5 minus 0, x2 was 8, and then you say minus 0. Now, this will just be y over x equal to 5 over 8. Now, remember that we're trying to make y the subject. So just take the x, just multiply both sides by x. When you do so, the y will stand alone. So this will become y equal 5x over 8, because the x has to multiply the 5. There's really no need for you to say 8 times y, because when you do so, you will still have to go and divide by 8 at the end of the day. So there's really no need. Now, you can then say that f of x, open curly brackets, it was just a single thing. Yeah, let me just say, no need for curly brackets. So f of s is equal 5 over 8x, and this happened at the location 0 less than x less than 8. That was the location that happened. From 0 down towards 8, that was the location that happened. Just that location. Okay, let's take a look at question number 4 without, should I say further ado, without wasting of time. So let's see. Yep, let's see. Question 4. Remember to hit the subscribe button, like this video, and share it across to your course mates. Let me still wipe this out. This is actually one of my long time. No, let me not say that. Okay. So question 4. Question number 4. Okay. Before I go into that, I think let me remove some guys so you kind of. What do you think would be the period of this function? It's actually a tricky one. What do you think would be the period? I don't really think the diagram is just somehow. But let's see. I think, and I know, that I can describe this period as 9. Yep. I can describe it as 9. I always make use of this start point stuff. So it started from here and it's going up. Started from 0 and it went up. So at y equal to 0 and it went up. I'm going to look for another location where that happened. This is the location where that happened again. So this location, starting from 0, please take note that the value of y on the x-axis is 0. So it started from this very point and then it went up again. So this is, let me say, start to finish. So if the middle here is 8, this has to be 9. So the period is 9 actually. Period is 9. Yeah, very, very funny guy. So period is 9. So what we're going to do is to describe this function with a little part making it up from 0 to 9. The little fragments from 0 to 9. So let's break it down. There's a straight line moving from 0 to 4, because this is 0 to 4. So we're going to describe that one. We're going to start describing that one first. When we're done describing that one, there's 4 to 6. There's 4, no, this is 6. This should be 7. So there's 4 to 7. We're going to also describe that. Then you're going to also describe from 7 down to 9. So that's not difficult. Let's get started. So question 4. When the first one we're doing is from 0 down to 4. So when s was 0, y was also 0 because it started from the origin. Then the next one, when x was 4, this is x at 4. When x was 4, y was also 4. That is the point here. Y was also 4. Because you know, when you're drawing your graph, you kind of put x here. X marks the spot. So this is 4 and this is 4. Okay. So x is 0, y is 0, and just like that. All right. Now the next thing you're going to notice is we're describing from 0 to 4 first, right? From 0 to 4 first. Good. Now from 0 to 4, what we're going to do is, what do you think this function will be, or what do you think will be the equation of the straight line? Sorry. What do you think will be the equation of the straight line? Because at every point of x, y would have the same value. At every point of y, x will have the same value. So this basically means that y is equal to x, or you could say that f of x is equal to x. You could just say that yeah, f of x is actually equal to x. You can say that and nothing will be wrong. So this is what we have. And that's looking easy and beautiful. All right. All right. Now let's proceed. Let's proceed. Now this happened at 0 less than x less than 4. That was where that happened. Now the next thing is from 4 to 7. Remember, it's not 4 to 6, 4 to 7, because that's where this guy ended. From 4 to 7, what happened? From 4 to 7, the value remained the same. The value remained the same, and the value was what? 4. The value remained the same. So since the value remains the same, I can just use at 4 less than x less than 7, the value of y was 4. So which means f of x is equal to 4. So this was 4 less than x less than 7. Now the next one is from 7 to 9. So from 7 to 9, so you could say at, if it's your choice, 7x 9. So this would then become y was 0. Because if you notice, this was directly on, this straight line here was directly on the x-axis. So the value of y will be 0. So this is y equal to 0. So this means f of x is equal to 0. And this was 7 less than x less than 9. So right now, let us describe, or let us write this should I say piecewise? So let's write it like that. So the first thing was, it was x at 0 less than or equal to x less than 4. It was 4 at 4 less than or equal to x less than or equal to 7. Oh no, let me not use this, guys. And then it was 0 at 7 less than x less than or equal to 9. So that's what that function will be. So that's what question 4. That's what question 4 is going to be. That's the answer to it. Question number 5. Question number 5. So for question 5, that's a beautiful one. And remember to hit the subscribe button, like this video, and share that across to your classmates. For question 5, the first thing to determine is, what is the period? What is the period? The period is 13. Yeah, the period is 13. So I noticed that, it is starting from this 0 here, going upwards. This is 13, going upwards also. Yeah, so it's 13. Yeah, it is. So that's the period. The period is 13. Okay, now since the period is 13, we're going to describe this function all the way from 0 down to 13. All of the little parts from 0 to 13. So we have 0 to 4. This is a line, 0 to 4. Then we have 4 to 10. This is another line, 4 to 10. Then we have 10 to 13. This is also another line here. So let's start. Let's start with the 0 down to 4. Let's start describing from 0 to 4. So when x was 0, that's the origin. When x was 0, y was 0. Then when y was, let me start from x. When x was 4, y was 3. Now, if you know the concept of rise over run, that is, slope is always how high you've gone divided by how well you've run. So the value of this, since it's at the origin, y will become 3 over 4 x. Is that weird? Okay, let's come here. Let's come here. So I don't really explain much. Let's come here. I don't want to explain much. If you notice, this is 0, 0, right? 0, 0. And this is 4, 3. This is 8, 5. Now, when you come back to this very part, this is 5 over 8x. So here, the value of x will come first. So that's 3 over 4x. So that's just the same thing. I don't want to just repeat the process, so I don't make the video very long. But if you understand this, because I solved this calmly, you can be able to also understand how this happened. Y is equal to 3 over 4x. You can also understand how that happened. Now, this occurred within or between the hours, should I say between the hours of, within the time 0 less than x less than 4. That's where that occurred. That was where that occurred. Okay, so if that's where that occurred, the next part is from this 4 down to 10. What happened between 4 and 10? So the first thing is, what is the point? Because this is a line, this slant line, Though the gradient here, the slope is going to be negative. So this is 4 to 10. So first of all, at 4, the value we have here was 4,3. Yeah, 4,3, because value of s was 4, value of y was 3 for that point. And this very point here, what will be the value? When s was 10, value of y was what? Minus 3. So using these two, we can get the equation of that very line. So let us say when x was 4, y was 3, that's this point here. When s was 4, y was 3. Then the next one, when x was 10, so this very point here, when s was 10, y was minus 3. So let's go by our formula. So y minus y1 over x minus x1 is equal y2 minus y1 over x2 minus x1. So this will be y minus, let us call our point. So this x1, y1, s2, y2. So this is y minus, y1 is 3, divided by x minus x1 is 4, y2 is minus 3, then minus 3, because we had it here before, and x2 is 10 minus 4. Okay, so this is y minus 3 divided by x minus 4 equal minus 6 over 6. Because minus 3 minus 3 is minus 6, and 10 minus 4 is 6. Now this is y minus 3 divided by x minus 4 equal to minus 1. As you can see, the slope was minus 1, so the slope is going to be negative. So it depends. There's a way I kind of know them. So this is minus 1. Okay, that's minus 1. Now what would I do next? Or what's the next thing for me to do? Let me cross multiply. So this will be y minus 3 equal minus 1 into x minus 4. Now you can kind of put over 1 here. Then you say this will times this. So 1 times y minus 3 is y minus 3. Then x minus 4 will be multiplied by minus 1. Let's open up the brackets. So y minus 3 is equal, minus 1 times x is minus x, minus 1 times minus 4 is plus 4. I need to wipe that part off the board. If you've not liked this video, like the video now. Like the video now. Okay, so next thing I want to do is to move the minus 3 to the other side. So I need to add 3 to both sides. So this is y equal minus x plus 4 plus 3. So this is y equal minus x plus 7. Yeah, y equal minus x plus 7. So this is y equals 7, take away x. It's just a fancy way of writing it. Just a fancy way of writing it. And where did this occur? This occurred at 4 to 10. 4 less than x less than 10. That was where that occurred. Now, is this the last? No. Remember that we said the period is what? 13. So let's take a look at the next part. The next part, we have a horizontal line. From 10 to 3 was a horizontal line. Yeah. And that horizontal line was minus 3. So y is equal to minus 3 at 10 less than x less than 13. So all the way from 10 to 13, the horizontal line that we had was minus 3. So now can we describe this function? Yes, we can say that f of x is equal to, open up, oh no, that's too small. It's still okay. So the first part was 3 over 4. So we've got 3 over 4x, and this was 0 less than x less than 4. Then next, we had 7 minus x. So this is 7 minus x, and this was at 4 less than x less than 10. And then last we had minus 3, and this was at 10 less than x less than 13. And yes, this is what it's going to be. That's what the answer to that question is going to be. And with this, I'm going to wrap up this video. Remember to hit the subscribe button, like this video, like it, and share it across to your classmates. I'll see you in the next one. Bye.